Okay, let's turn our focus to global greenhouse gas emission and where is it coming from. Now, compared to the pie chart that we're seeing with the U.S. Greenhouse gas, the global greenhouse gas emission largely looks the same. With again, the primary greenhouse gas that we're dealing with is carbon dioxide, and then methane, nitrous oxide, and the fluorinated gases. Now, the economic sectors of where it's coming from, this is pretty obvious. Electricity and transportation accounts for a huge part of it, and then industrial production. However, I think agriculture typically kind of flies under the radar, but in most countries, agriculture is easily the primary source, or at least the second when it comes to greenhouse gas emission. Right. Now let's look at carbon emission from fossil fuel. Okay, and as with most of these time series data, what the period that we're going to focus on is going to be the pre-industrial period. And so we can see here starting from the Industrial Revolution with coal, 1900s with the petroleum revolution, and then as societies become more developed, we have more infrastructure and pipelines, we started using more natural gas. Right? And this has just been an exponential increase, not a linear, but exponential increase in the amount of carbon emissions that's emitted from fossil fuel. One side note here, this is the global carbon emission, and so for any activity to show up on this graph is pretty significant. And what we see here is cement production is a very extremely carbon intensive activity. But also, I'd like to bring your attention to gas flaring. Now, for those of you who don't know what it is, gas flaring is the activity of simply burning excess natural gas. Now, so this situation usually occurs during oil drilling, for example. So the oil company might be drilling for oil, but unfortunately, what accompanies through the extraction is natural gas, and oil companies typically aren't equipped to capture that natural gas. And the alternative to simply letting the natural gas out in the atmosphere is to burn it, is to simply set it off. Right? And so that is a tremendous source of inefficiencies that deserve a second, that deserve a few, deserve more attention, I think. Okay, now where or what region specifically is it coming from? Okay, so here we can see, right? We can see this is breakdown a carbon emission by countries or by world regions, right? And we see that in the first 100 years, it's 100 years back, United States and the European nations, right, are the major polluters, and for a long time, United States is the number one CO2 carbon emitter in the world. However, in the 90s, Asian Pacific countries, particularly China, starting to catch up, and now since 2012, actually, China is the largest polluter of CO2 emission. Okay, now here is a great resource. So let's take a look. There's the link here. It's a great resource to look a little bit deeper into CO2 emission. Okay, all right. So our world in data. These are people based in Oxford. Not only this site have a rich resource in data on just about anything actually. COVID pandemic, I've been utilizing their resource a lot when I teach statistics, and so I definitely recommend spending some time on this site and utilizing their resources. But not only do they have a rich a set of data, but they also compile them into these easily accessible and comprehensible graphs. Right. So let's take a look at the CO2 emissions by country. So let's take a look at the United States, for example. And so here's the country profile, and what we see here is on a per capita. So the per capita is a good measure. It's to take a total CO2 emission divided by the population, and we can see here. For the United States, right? We peaked in the 70s, and since the early 2000s, we have made tremendous progress, and we're now we have reduced our carbon footprint by quite a bit on a per capita basis. Now, another country that is good to look at, and I mentioned them in chapter 11, is Germany. All right, so as I mentioned in chapter 11, Germany invested more so than any other developed compared to other developed countries. They invested heavily into renewable energy, and they made tremendous progress in reducing their carbon footprint as well. Right, and we can see here, right, they're significantly have a much lower carbon footprint per capita than versus the United States. All right. Another country that deserve a look at is France. Now, why do I mention France? Well, France and Germany, they're both European countries. They have a close, not just in terms of culture, but also in terms of simple proximity. They're they're right next to each other. Industry wise, they have similar size economies, similar size living standard, health standards, and so on. So they are different, but but for the most part, right, they're pretty comparable. Okay. Now, if we look at the carbon footprint in France, right, here is something that's quite alarming, actually. Right. So we mentioned that Germany invested heavily into renewable energy, right, more so than any other developed nation, and yet France is able to achieve almost half of the carbon footprint compared to Germany. Okay, all right. Now, if we are concerned with carbon emission, and we are, right, I think this deserve, right, this shouldn't escape anybody's analysis. Right, we should really pay attention to what exactly France is doing, and now so long story short, is that France invests heavily in nuclear, along with several other Scandinavian countries, and now the viability of nuclear energy and how safe it is, and is it the best solution? It deserves a more detailed conversation and discussion that we are not going to have enough time here. Although I do believe that definitely should focus more on nuclear energy, but that is a separate discussion. But regardless of what you think, I think the evidence is clear that nuclear energy, right, is able to achieve significant progress, when we talk about carbon emission. Okay, now nonetheless, let's go back to talking about trend. Right, so we have these developed countries, the OECD countries, and we see this downward trend in carbon footprint in the CO2 per capita. Okay, and you can pick any OECD countries, and largely you will see the similar trend. Now, let's look at, as we saw earlier, right, China, along with other developing countries, right, they have made the biggest change in carbon footprint in recent years. Let's take a look here, adding China in, and we can see that here in the early 1900s is almost non-existent because China at the time was still using mostly biofuel or biomass. But then in the late 1900s, and really around 1990s is when this exponential growth in the economy begun. And we see that here, and remember, this is CO2 per capita, right? So CO2 emission per capita, and in this short amount of time, China has bypassed now France. So China actually has a higher emission per capita than France. And also keep in mind that China is the most populous country in the world still, right? And this is the trend, right? This is the ongoing trend. Now China is talking about peak emission, and so it is. So we will still, have to wait for the data to come in the next few years to see if they have achieved that. Now let's take a look at another large but emerging country. just India. Now, India, their trend, their current emission is similar, basically where China is back in the 1980s. Now, if we can look at China as a model of this developing, large developing country, then we have plenty of reason to believe that India will also experience this exponential increase in the carbon footprint. And also keep in mind this, again, this is per capita, so India, is has over 1 billion people residing there, right? So this is the trend, right? And this is where we want to focus on when we are talking about climate change policies. Okay, let's come back to the slide here. So, what is the result? So, we have economic development, and we know where the source is, and we know which region has been developing and will be developing in the coming years. And what is the result? So, first, right, we see this evidence of CO2 increase in CO2 concentration, and so. Thankfully, we have data that can go back to hundreds of thousands of years. So this is going back over 800,000 years, and we are at a CO2 concentration that higher than at any point, at least 800, from 800,000 years ago, up to 800,000 years ago. Okay, looking a little bit closer, right, we can see that we're still increasing. Right, we're still increasing. Consistently over the past 60 years, and so just within the past 60 years, right, we went from 320 parts per million to over 400 parts per million. Looking at it even more closely, we see that here, this is from 2015 to 2020, right? We are at over 410 parts per million. With no sign of decreasing. Right. Now, couple notes here. What we are interested in is this black line in the middle. That is the running average. Just think of the average, the trend, right? Think of that as the trend, right? That's what we want to focus on. This red is the real time, month to month. A month-to-month measurements, right? This is the seasonal fluctuation, right? That occurs every year, right? So in a given year, you're going to get high concentration and the low concentration. But again, what we care about over time is this trend. Right? Now, so what are the effects? Okay, so a couple of effects that we want to pay attention to from a policy perspective, especially when we're thinking about climate change as a global pollution, a global issue, right? I think we need to pay attention to the ocean acidification. So here is a really good resource, a good video that I recommend taking a look. And basically, what the video emphasizes, and the reason I'm adding this here, is the connection between ocean acidification and food scarcity. So. For many developing countries, especially the poorest countries, they rely they rely on the ocean as a big part of their diet, and so not just diet, but also economic activities. And ocean acidification, right, will impact ocean acidification caused by climate change will impact those regions the most. Okay. Now, what will impact them in those regions the most is also sea level rise. Right? And here we're looking at compared to pre-industrial time, right? So if we set the pre-industrial sea level at 0, and now we can see that we are over 9 inches of sea rise compared to pre-industrial level. Okay. But of all the effects, the impact of climate change, the one where we're going to focus the most on when we talk about policy is going to be temperature. Right. And so again, here is the temperature. Here is the temperature increase, and then we're looking at also looking at compared to pre-industrial time. Now, this particular graph chooses the average of 1960 to 1990 as the baseline. So that is the 0 degree here. So that is 0 degree. So we can compare pre-industrial, which is negative. So basically, a pre-industrial at pre-industrial time is 0.4 degrees Celsius below the 1960 average, and currently we are zero point 0.6 degrees Celsius above the 1960 to 1990 average. Okay, all right. Now, so those are so that's the effects of climate change, and now we're going to focus on this temperature change, and we're going to talk about the IPCC report.